All right, good morning, everyone. We are officially live now, and I was told that we have to stay strict on schedule, so we're going to get started. I see many familiar faces, but in case you don't know me, I'm Vladimir Kozlov. I'm founder and chief analyst at Light Counting market research company. Light Counting is celebrating 20 years in business today, and we build our reputation on providing the data with information on what the market is today and forecast for the next 5 years, with an objective to bring more transparency to the market. And I think our second objective is to help new technologies to get into the market. And we're hosting this session with many startups presenting their work, addressing some of the bottlenecks in the industry as we see it. So this is one of many charts that we publish and update almost every 3 months now. So we track sales of Ethernet optical transceivers. And this chart kind of separates demand between AI clusters and non-AI markets. And non-AI markets include legacy segments such as enterprise networks, telecom networks. If you look back 10, 15 years ago, Ethernet was mostly used in enterprise networks. Telecom was the second largest market. And then in 2010, Google started, well, actually, they started 2007. But 2010, the volumes really picked up for deployments of Ethernet transceivers in cloud data centers. And this market has grown quite rapidly over, since 2010. If you look carefully at 2023, the market for non-AI application, including compute nodes in cloud data centers, actually declined. So this AI boom came just in time to save the market from a decline last year, and this year we expect 40% growth. Our forecasts tend to be on the conservative side, so we hesitant to project strong growth for more than a year or two, and mostly because we've seen that over the last 20 years that market segments tend to grow fast for 2 years, maybe 3 years at most, and then there's usually some kind of a slowdown, which is very hard to predict. But we are hesitant to publish exponential growth because we just know from experience it rarely happens. The next chart is going to look specifically at demand for AI clusters. So we kind of zoom in on this red category shown here, and we also look at number of units of transceivers instead of sales. So you can see that last year about 5 million transceivers, Ethernet transceivers, were deployed in AI clusters, and this year we expect about 11 million units, and majority of these are 800 gig devices. As you can tell from the chart, NVIDIA almost overnight became the largest consumer of optics. And they don't necessarily the end user of optics, but a lot of optics is going through their hands. And their largest customers like Microsoft prefer to deploy fully equipped systems from NVIDIA, including the optics, not to mention the software as well. So NVIDIA manufactures optics at their contract manufacturer, Fabrinet, but when it comes to really high volumes, they engage suppliers, so they work with InnoLight, Coherent. They are qualifying other suppliers for their next generation 1.6 terabit transceivers. But it's not the only option for the end users. So companies like Meta, for example, prefer to buy optics themselves. And Drew our next presentation is from Meta, and Drew may tell us more about it, but our understanding is that Meta buys a lot of GPUs from NVIDIA, but they build their own switches, they buy optics directly, And in the future, we think that more customers will follow that direction. So the contribution of NVIDIA in terms of selling optics to the end users will actually decline. I mean, they'll probably remain dominant in sales of GPUs. But the other story is that, the growth is very high. And as I said, this forecast may be conservative, and I'll explain why on the next slide. Well, first of all, maybe stepping back, why the demand for optics is so significant. So what NVIDIA did 2 years ago, they announced an additional network. They call it a GPU to GPU fabric. And there are plans to deploy optics for this network. So the blue network on the top of the racks was always there. So they call it data center network, and it relies on InfiniBand. Until the last generation, most of the optics were active optical cables. With the most recent generations, they transitioned to optical transceivers, which, gave a boost to transceiver market. But more importantly, they started using a lot of optics in this yellow network in the middle of the rack. So this is GPU to GPU fabrics. So that's at this point, they're still using InfiniBand. So InfiniBand goes through NICs, and every GPU has, I think, one 400 gig port. They use 800 gig transceivers because they can combine two ports in two 400 gig ports in an 800 gig transceiver. But the most interesting part, at least for me, of announcements of NVIDIA from 2 years ago was that they're planning to transition from InfiniBand to NVLink for optical connectivity. And once that happens, the demand for bandwidth could increase quite sharply. Quite sharply, meaning by a factor of 10. So if you look at this chart, there is, even in the, this is not the latest generation of GPUs, that's from 2 years ago. Each GPU had 3.6 terabit of bandwidth. And once NVLink is going to become the protocol for this fabric, they will have to use all of that bandwidth to connect GPUs with NVLink. So we're moving from 400 gig per port with InfiniBand to 3.6 terabit per port with NVLink. For this generation of GPUs, NVIDIA built a cluster with NVLink over fiber internally, but they haven't made it available to the end users. And my latest conversations with NVIDIA is that they're still resolving issues, how to enable NVLink over fiber connection. It was never designed to work over fiber. So they're still working on it. It's possible that as early as next year, we may see first deployments of NVLink over fiber. Not sure if it's going to be 800 gig transceivers. Most likely it's going to be 1.6 terabit transceivers. And this type of disruptions are very hard to predict. So our forecast is probably not accounting for this additional bandwidth coming. But it is coming. The question is, what we don't know is when and how quickly the market is going to migrate to it. But even with the current forecast, demand for Ethernet transceivers is growing very rapidly, and it's shown on the right side of the chart. The left side shows copper cables. And copper is not going away. I mean, in fact, NVIDIA is using even more copper now in their latest systems because their servers now, that used to be a box, now their servers are full rack. So whatever copper connections we had on PCB boards migrated into copper cables. So again, I mean, this chart that shows very rapid growth does not account for the type of cables that NVIDIA is using in their racks. In their latest generation, because the numbers there are quite staggering. So we'll still have to figure out, how do we start accounting for for the latest designs of NVIDIA servers. So if you step back and look at applications of optical connectivity and copper connectivity in different parts of the network, for InfiniBand and Ethernet, optics already accounts for about 75% of ports because these connections are typically between the racks or even between the rows. If you look at NVLink connections, at the moment all of it's copper. The only reason we have a little bit of optics in the next row of the circles is because Google is using optics for direct connectivity between TPUs. And they call it intra-core interconnects, or ICI, which is kind of similar to NVLink in terms of functionality, but it's a different protocol. In case of Google, they actually designed it to work over optics from day one because they also use optical switches to enable very large TPU clusters. Our expectation is that 2-3 years from now, maybe even 2025, NVLink is going to start running over optics, and then we're going to see more optics in this category. These are mostly kind of shorter reach type of connections, but anything between the racks is very likely to be optics. Connectivity within a rack, I think, is going to stay copper. And then the last set of circles shows connections to off-package memory. And there is a bottleneck in terms of how much memory GPUs need. So there's, designers are trying to put as much HBM or high bandwidth memory as possible next to GPUs, but it's still not enough. So the company is developing optical connectivities that could add more HBM to GPUs. There are other types of memory, including CXL type of connections that are being developed. One common barrier for deployments of optics in connections to memory, and it's actually an issue across the board, is reducing power consumption. So current designs of pluggable optical transceivers are about 10-15 picojoules. With linear drive optics, whether it's pluggable or co-packaged, we can get to about half of that. But what designers really would like to have is something on the order of 1 picojoules or less, because that's where kind of electrical interconnects are today. And we don't yet see technologies that could deliver this type of power efficiencies. So as part of call for action, we're asking the community to come up with new ideas to see if it's even possible to get to this level of power efficiencies. Another very important issue for the end users is reliability of optics. And it's always been an issue. But for AI clusters, it's even more important because AI workloads really don't like any kind of disruption. And when a transceiver fails, it could really slow down the model and create a lot of headaches for the operators. In case of Google, that's one of the reasons they use optical switches, because it helps them to reconfigure the system. Whether it's a TPU that fails or optics that fails, they can still reconfigure the system and keep it running, bypassing problematic node. But ultimately, better reliability and better lasers are needed. So we see a lot of progress in quantum dot lasers. There are only 3 suppliers at the moment. All of them are small or mid-sized companies. But quantum dot lasers have significantly better reliability and much better performance at high temperatures. So we do see direction for improved reliability in the future. It's not going to happen overnight. I think, first time we've seen transceivers with quantum dot lasers was at this year OFC. Typically, it takes about 2 years from OFC demos to real deployments. And then it's a question of building up enough capacity for this quantum dot fabrication. Another way to look at the transceiver market, and in this case we look at all optical transceivers, so not just Ethernet, we look at DWDM transceivers used in long-haul metro networks. We look at fiber home transceivers used in wireless front haul. So this is total transceiver market, as we call it, and it's split by different technologies, specifically looking at optical modulator technologies. So silicon photonics was a big story over the last decade, and we expect it to continue to make progress. In fact, better reliability of silicon photonics modulators was a key for success of this technology. And it's certainly more compatible with co-packaged optics, and even linear drive optics seems to work better with silicon photonics modulators. But we also see other technologies, such as thin film lithium niobate, so that's kind of shown in purple on top. And bulk lithium niobate has been kind of the workhorse of the industry over the last 3, if not 4 decades. But now companies learn how to make thin film lithium niobate on silicon photonics platform, and these modulators are faster, they're more transparent. So we certainly expect to see them come to the market. So I think, as a conclusion, this is just a kickoff of the session. I think the problems that we're facing will have to be solved by many small steps. I don't see a big breakthrough that's going to come and change completely the industry. But it's the small steps, like new materials, new structures like quantum dots, new device designs. So I think we have to look at the whole variety of solutions to be able to get to the metrics that the end users are asking for. Thank you, and I'll take a question or two if you have any. Well, if you don't, you do have questions. All right, go ahead.
So you mentioned many small steps. Like, what does your research see? When do those small steps accumulate into, okay, now we have a solution that is viable?
Don't hold your breath on it. It takes time. It takes time. I'll point out to this slide. I think it was 2012 when Cisco acquired silicon photonics startups. And some of the analysts predicted that, okay, 3 years from now, everything is going to be silicon photonics. Finisar is going to be out of business. And that was 2012. In 2022, 10 years later, yes, silicon photonics is part of the market, but still about 20% of the total. So it takes a decade. If you think it's going to take 2-3 years, most likely it's going to take a decade. So we have to be very patient how to do it. I think what also matters is decisions by the largest customers. It was Google in the past who kind of led the industry towards PAM4 modulation, for example. I think NVIDIA now is going to be the one who is going to make decisions which optics they're going to deploy, and they're in a position to kind of route the innovation in the industry probably over this decade, if not into the next one. Go ahead.
You probably know about PCIe attempt to bring optics to PCIe, PCIe over optics cable. Where does it fit in your numbers?
So it's not in our numbers yet. It's kind of in this category on the right. So it is a lot of bandwidth. The challenge with PCIe, it's a little bit behind in terms of generations, but it will happen. Probably by the end of the decade, we will see optics, CXL for PCIe as well. So you just have to be patient with it. So I'm going to stop here because I'm out of time.
One more question, Vlad. Yeah, I think
Just fast one.
Yeah.
How do you see the impact with the BABA situation in US? Are the big guys you mentioned are not willing anymore to use China or Taiwan? It was a clear message during OFC 1 month ago. Then do you see an impact on everything you have been telling us here?
It's not an easy question. So let's keep it for the panel discussion because we're out of time. I'm going to introduce our next speaker, which is Drew Alduina from Meta. And welcome, Drew.